All right, everyone. Welcome back. Let me put this. Oh, hang on. Okay. So, today I think we'll discuss more about classes. We'll talk a little bit more about Exam 2 testing, and that's it, basically. All right. So, I guess without further ado, let's begin. All right. Let's say classes 2. All right. So, if we're going to review what we did on the previous day, so as I've been saying in class for the past 2 weeks, approximately, Exam 2 is going to start on the 15th, so next Wednesday. And what I mean by start is that Exam 2 will be, it'll take the form of probably 2 parts. Maybe I'll just write it all down here. So, part 1 of the exam is going to be a multiple choice question thing. It might be on Blackboard, or possibly using the Respondus. Basically, whichever feature we find is the easiest for giving you multiple choice questions. It's going to be approximately let's just say approximately 10 to 15 multiple choice questions, and that's what part 1 is going to be. Part 2 is going to be the main focus, which is going to be basically, I think what I'm going to do is we'll probably give you 3 coding questions. And so the target is that they're going to be sort of like lab difficulty, mostly difficulty. So they're not going to be quite as hard as homework problems, but they will be submitted on GL. So the idea is that they're going to be about lab difficulty. Maybe we'll put a little lab plus. They'll be slightly harder than a lab, maybe. Not up to the same difficulty as a homework. Okay, so there'll be 3 coding questions. Well, so normally, right, on the physical exams, the questions that we ask you for coding are, so back when we did paper tests, the questions were like lab minus. They were significantly easier even than lab questions. So moving them online and the fact that we're going to give you a few days to do them means that we're going to say maybe lab plus. So they'll increase in difficulty a little over the first exam difficulty level. Like this was paper tests. The reason why on paper tests questions have to be a lot easier is because you have no access to PyCharm, you have no access to a debugger, you have no access to the internet, you don't have any resources. Basically, you're just literally writing down code from memory and whatever you can problem solve. And so that's why those problems are so, I would consider them usually so much easier than the standard even lab. So and then there's going to probably be two debugging. Let's see. Questions. The format of the debugging question is going to be something like, basically what the debugging questions are going to be is we will ask you to copy some code from the GL server. So you'll copy a file, and it'll have a description of what the code is supposed to do, right? It'll tell you what it's supposed to do. But it'll have some syntax errors, so it won't run maybe, and it'll have some logic errors. And so my idea for this one is that you should fix the errors, and then maybe maybe we'll have you say copy, oh no, not copy. What I meant is comment the fixes. So you'll be required to explain what you did to fix that bug, whatever it was. If it was a syntax error, and it's really simple fix, like, oh, that's just not something that's allowed. Say you have, a function that's missing an end parenthesis or something like that. You can just, you can just say that. But if you just have some function that has, x, y, and it's just missing something, you can just comment, added. And the bugs, so we will play with the difficulty on the debugging question until I think it's reasonable, which means that the debugging, the logic errors cannot be too extremely intricate. They have to be pretty simple. I would say that the bugs can be slightly more involved because you guys are going to be allowed to use PyCharm. So hopefully you'll be able to find all of the syntax errors and fix them at least, right? Because hopefully by the end of the, I'm guessing we're going to give you something like a 3-day window for the exam. So maybe the exam will really be from the 15th to the 18th, something like that. So in this 3-day window, you will be able to fix the syntax errors. For the logic errors, we'll try to make them something. I mean, generally, what we do on the exams is we try to make the errors pretty obvious. They're not things that are so tricky that there's only like one case out of a 10,000 cases that's ever going to trigger that error or something like that. So we'll try to make the errors, say, moderately obvious. But of course, moderately doesn't really mean anything. So, okay. So that's the current idea for the exam. In terms of a practice test, I will try to write up some practice multiple choice questions. I'll try to write them up tomorrow and send them out. I don't want to make too many promises. I'll try to start writing them up tonight, but I don't promise that I'm going to send them out tonight. So maybe tomorrow I'll send them out. Yeah, so the multiple choice is going to be all on the 15th. So it'll basically be due on the 15th. I don't want you guys spending too much time on these multiple choice. Yes, so the homework and projects and labs and stuff will continue as usual. Oh well, we don't have, so there's no labs on exam weeks. But other than that, yeah. So for the multiple choice, these are just going to be questions that are like built there to make sure that you check the boxes. So, if we let you out of this course, at least you can say that you know the things that are on the multiple choice section, which means that you had better learn those things. And we'll try to make it, I'll give you some practice MCQs so that you can kind of play with those. And I'll try to write up some practice coding problems and debugging. And I'll try to write up a sample solution. Basically so that everybody knows exactly what we expect when we kind of roll into this thing. But I think this is a pretty complete description of what I expect on the exam. So, okay. All right, so that was a lot about what the exam's going to be. I think that's probably too much class time spent on that, but whatever. Yeah, so I will just try to get you some practice problems and practice MCQs and stuff, so that by the time you get to the exam, there won't be a the question of what the heck is this thing going to be won't be your main issue. You'll just be like, okay, this is the format, and you're gonna submit this stuff on GL the same way you submit homeworks and labs and projects and everything. So at least for the second part of the exam, it's gonna resemble more like a quick homework. For the multiple choice questions, we'll see what we can do to make it something that's kind of basically the point is that anything that's, I just want to make it something that's kind of useful, and I want to make it things that if our basically they're the need to know things. The things that I think that you should know, but it's kind of hard to test them with coding particularly. Okay, so let's get back to, so that is, you will have 2 more projects. So yeah, so this class will have 1 more. So we have 1 exam 2. Then we have 2 more projects. So we're gonna have a project 2 and a project 3, and then, well, the point distribution is gonna look the same. We are not changing the syllabus. For the exam, I'm gonna say that approximately 25 points on the multiple choice question, and then approximately 100 points on the coding stuff. So each of the coding questions is going to be about 20 points. The debugging questions are going to be about 20 points. So yeah, so for the rest of the course, then we have project 2, project 3, exam 2. Technically, we still have homework 6 that's, released but not yet due. And we'll have a few more labs. I don't know. I think this might be the last. I think there's no more pre-lab quizzes. Which, I don't know if you guys understand how happy that is, if you guys never have to do another one of those. Yeah, so homework 6 is the last homework. After that, we just do these 2 projects. And then, of course, the final exam, which I think in terms of format, if the exam 2 format works out, it'll be similar to the exam 2 format. And of course you say, well, what's the exam 2 format? Well, we've just spent a long time talking about that. So I think that I can kind of just say whatever happens on exam 2 is similar things should happen on the final. Okay. All right. And I think that's it for the course. So some more labs will happen, but I think there's no more pre-lab quizzes after the last one that you just took. So, thank the gods for that. Okay. So, yeah, let's get back to classes. So let's just talk about classes a little bit. So the idea of a class in Python, and I know that I've shown you how to create them, but generally there's two words that you'll hear when you talk about classes. You'll hear abstraction and you'll hear encapsulation. Well, the idea of encapsulation, at least, is that you'll have functionality placed within an object and that basically it's like related functionality. Maybe we'll say related functionality is placed within an object. So you'll have a bunch of different data and you'll have methods that are all kind of related to the same thing, whatever that thing is, the idea of that object. So for instance, if it's a character, then it'll have some stats, it'll have some things that the character can do, actions that it can perform. And then there's abstraction, which is basically, I guess the simplest way to say it is to hide some of the guts of software away from the end programmer. Basically, the idea here is that, for instance, you know, when you call like a string dot strip or split or whatever, that function, you don't have to implement that function. So actually, functions are one form of abstraction. So one of the basic forms of abstraction is functions themselves. And then another form of abstraction would be classes, because classes can contain methods, which are functions, and variables. So basically the idea here is that a class abstracts some of the functionality away from the end programmer, so they don't have to look at all the code at once. They can kind of just access your class and have your class perform some of the required operations, we'll say, on the data, and it encapsulates functionality within a single object, which allows for easy access, right? Because, I mean, even a string, in a sense, is a class. And, you know, an example of this is like the string in Python, which it definitely has a ton of methods that you can call on a string, right? That'll do string operations for you, which is pretty good because generally you don't want to have to rewrite string operations, unlike in some other languages, you know, like C++, where a lot of string operations are not written for you unless you include kind of more advanced libraries. So, all right. I think that's it for the kind of idea of a class. So let's get back to actually coding. So remember, that if you're going to declare a class, all you have to do is go class, and then the class name. So what's the class name? So of course that depends on what we're going to do. I don't know. We've been talking about exams, so let's make an exam class, right? So, you know, what kind of things should be data? So if we have, so remember that every class well, I shouldn't say that every class has a constructor explicitly in Python. What I do mean by this is that every class has a constructor. If we declare it, it's called init with the double underscores on both sides. And then you have to remember, again, this is kind of a review, that whenever you make a function inside of a class, the first thing that that function has to take as a variable is self. And so the reason why it takes self is so that you can access self.stuff. And so what I mean by that is, for instance, if we say self dot, you know, multiple choice, and we make a new list, and then we can have self dot true false. We can have self dot short answer. And so we're making a whole bunch of lists. And so, you know, we can have various things. So what kind of things does an exam do, for instance? I guess we can have an add multiple choice question. Or we can have, say, the prompt and, say, a list of options, right? And then maybe an add true false question, which doesn't need the options because the options are true false. So basically you would just say the prompt. And I guess you could have an add short answer, which would also have a prompt. Okay. So that's basically, for instance, this is like an exam class, right? And so, for instance, if you added a true-false question, you could just go self.trueFalse.append the prompt. So let's make this class do something. Yeah, so let's make this class actually, let's make a giveExam function. So in this giveExam function, maybe it'll give the true-false questions first. So maybe for question in self.trueFalse. And I mean, I'm not sure how much I'm actually going to write of this class. I'm just doing all this as an example. You could say something like print out the prompt, or I guess it's question now. And then you would say input, and the prompt that we're actually going to ask is enter true or false. And so maybe we would say while t or f dot lower is say not in true false. We could do try again. So this is not actually a terrible example, because at least now we have a class that has some functions, and these functions actually do things. So it's not a terrible example. Okay, so let's make an exam, right? So let's say random exam, right? is equal to a new exam. And so what is this exam going to have? So maybe we'll add some questions. We'll add a true-false question. Maybe we'll add 3 true-false questions. So first one is going to be, is the sky blue? And, oh, you know what we could do? We could add a true-false question where we have a prompt, and we could have whether or not it's true or false. So we could actually just say, something like that, and then we could just say this. So the sky is probably, let's say the sky is blue, so we'll put true in here. And then we could say, is the space Pope reptilian? And the answer is true. And then we could ask, is 3 an odd number or an even number? And the answer to that would be false. So now we've added 3 questions to our test. So the space Pope is not a donut. The space Pope is reptilian. Let me see if I can find. Yes. Here we are. There we go. Proof complete. So, all right. Let's have the thing graded. It's from Farscape, or not Farscape, from Futurama. All right. So let's say if T or F is true, let's say dot lower, and yeah, basically QED, right? And say that the question 1 is true. We can even just say is true. We can say print, you are correct. Else, print, you are not correct. So, all right, let's see what happens when we do all of this. So we see now that, oh, I should have put some spaces here. So is the sky blue? Let's say, I don't know, it's kind of gray out, so I'm going to say false. Oh, I'm not correct. Is the space Pope reptilian? Yes, of course. Everyone knows that. True, you are correct. Is 3 an even number? I don't believe it is. Ah, nice. Wait, you are not correct. Ah, because I never added the false condition for the answer. There we go. That's why you should test your code before you run it. But whatever. Cool. So you can see how maybe you would add stuff for these. I'm not actually going to implement these functions. I think that this example has been done to death. I mean, obviously, you could say options and then maybe the correct answer, right? And that way you could encode whether or not you got the question right for that. Short answer questions, obviously, Computers have a very hard time grading those because it generally involves people reading students' answers and determining yes or no. I guess you could always just check it against some string. You could say something like answer string, but that would be that would require some level of AI. Oh yeah, so what does self do? So what self does is self allows you to access whatever class is calling the function. So for instance here, I'm creating an exam instance. So basically exam is the type of class. Random exam is what we call an instance of the class. So what we mean by an instance is it's an object that has all the variables. So an instance will have all three of these variables inside of it, and they're unique to the random exam class. So if I create other exam is equal to exam, and I print out, for instance, other exam dot say true false, what we're going to get is nothing. Well, okay, is the sky blue? False, false, false. Okay, but you see at the end, it printed out other exam dot true false, which are these true false questions here. The list here is empty, whereas if we print out, actually what we can just not give the exam, and then we can say random exam dot true false. So you see that for the first one, it doesn't have anything in true false, and in this one it does have something in true false. And the reason is because every instance of a class gets its own set of variables. So each instance gets its own internal variables that are not shared. And of course, I shouldn't say this right now, but there's a gigantic exception to this, which are class variables. But I am not talking about class variables right now, so I'm only talking about instance variables. I will talk about class variables probably later today, so just keep that in mind, but I don't want to say too much. Anyway, so each instance gets its own variables, and so in order to access the variable that's attached to a class, you have to say self dot and then self dot true false, or self dot short answer. And what that's going to do is it accesses the class that called, I should say, really, it should say the instance that called this method, and gets the variables from that instance. And so that's what self does. All right. Cool. So I think it's pretty obvious to see why classes can be a pretty important feature in development, and the reason is generally because classes allow you to kind of stick in a whole bunch of functions and a whole bunch of variables into a single object that acts just like another variable, and then you can kind of pass that variable around, and that variable has all these functions still attached to it and all the variables still attached to it. So it's something very useful. Incidentally, when you pass a class in, so if you say if you create some function, say let's see, what's a good thing to do to an exam? So give, and say we have a list of students, and we have the exam to give. And so this class is going to say for student in student list. And so the question that you might ask is, so if this is a list, remember that Python passes lists as mutable objects. So it passes them what we call by reference. So the question is, do classes pass by value or by reference? And so the question is whether or not classes that are passed into a function, so the question boils down to, does a class passed into a function get copied or just renamed as a local variable? But still references the original class, or the original instance, I should say. And so the answer to that is that unlike primitive data types, so remember primitive types like int, bool, string, float, they are immutable, but they are passed by value. So that means that every time you pass, for instance, some kind of number or a string into a function, okay. Okay. Looks like the stream might have glitched for a second. Classes behave more like dictionaries and lists, which means they are not copied. They are passed by reference. So let's do an example of this. So let's make a silly function, basically a modify exam function, and it's going to take some exam. And so what it's going to do is it's going to say some exam dot add, say, true false question, and so we're going to add the true false question. Does this modify the original exam? And the answer is going to be true. So let's test this out. Let's see if this is right. So let's take, I don't know, let's take random exam and modify it. So first we're going to print it, well actually, good, we've already printed out the random exam true false questions. So now what we're going to do is after the function is done, so we're going to print some exam.true false to prove that it's actually adding it. And then we'll print random exam.true false again. So we're going to print three things. We print out the true false questions before we go into the function. We print out the true false questions after we modify the exam, and then we print them out after it leaves the function. So remember, if it passed by value, this wouldn't change. If you pass by reference, then this is modified. So okay. Okay, so let's run this. Cool. So we see here that this is the first print statement. So this is the print statement before we go into the function, which just is printing out the true false questions. This one, on the other hand, is printing out the modified thing, but remember that's inside of this modified function, so that's not a surprise. Even if this exam was a copy, this would still be modified. And then finally here, it prints out random exam.true false again, so here it's the modified one. So what that means is that whatever you do to a class inside of a function or inside of itself, it's going to modify itself, or a function can modify the original class. So it does not make a copy, it only modifies. So that's something to keep in mind when you do more development about this. Okay. So, good, that's Alright, I'm going to try something dangerous to see if I can get the chat back. Give me a second. Okay, I got the chat back too. Okay, cool. So, basically, yeah, oh man. If you only knew, Danger Will Robinson. I watched quite a bit of the original Lost in Space when I was a kid. It was playing on the Sci-Fi Channel essentially non-stop in the late 90s, early 1000s. So I watched quite a bit of that. All right. Good. So let's move on and actually talk about, well, let's just do a little bit more with classes. So there's, when you get into 202, you'll talk about inheritance. I might talk about inheritance maybe in another class. I don't want to talk about inheritance yet. I'd rather do some more basic examples of classes before we go on to something like that. But yeah, I mean, the goal of this the teaching classes right now is to just give you guys an introduction to what they are, to how they work, and then in other languages you'll see that they do kind of similar things. So, okay. So what do I want to do? Let's go to the grid game. So I had this idea that we would implement a grid game. And so maybe if you were going to implement a grid game, you might implement like 4 classes. And so here's an example. I mean, this is all just coming out of my own head, but this is kind of what I would think that you might try to do if you were going to implement, say, a grid game. And what I mean by a grid game is, let's say it's kind of like Pac-Man or something where you're trying to find your way out of a maze, kind of like what you guys have already implemented in terms of, going off of some kind of square grid. But if you were going to do it, quote unquote, the right way, if you're going to do it in an object-oriented way, you would implement it kind of maybe in something like this. So you might implement a grid class that represents like the grid itself. You might implement some kind of character class that has some stats, right? So like character stats are going to go here. In terms of the grid, it depends how detailed you want the grid to be. You know, we could have a position, I guess characters. So here's the position of the character. Maybe I'll make it a list so we can modify it. Actually, I don't know that we have to modify it in that sense. We can just replace it every time. Either way. And then so for instance here, you would take in probably some grid file, and you would probably process the grid file, at least maybe a grid file name. So you might have some kind of load. grid file function. And I had an idea that maybe you would have some kind of gremlins or something. Gremlins would be little characters that just kind of move around and try to eat you. So you might have, so a gremlin might have a position, you know, say 2, 5. Of course, this would depend on exactly, and maybe self.symbol. If we're going to do this all in text, then maybe we'd make it a G, or maybe some of the gremlins can have different symbols or something. Let's do it this way. Cool. And then what do gremlins do, right? So when you, yeah, something like Pac-Man, right? That's kind of what I'm envisioning here. I got that in my head. I'll upload whatever we write here, and then maybe so what do gremlins do? Gremlins, basically they just move. So and I don't know what move is going to do. We'll see what we decide for all of this, and I guess characters move as well. So this would be a good time to introduce inheritance. Maybe I'll use this example to do inheritance later. And so so let's look at what the grid game is going to have to do. So this class is going to be the whole shebang. So this thing, basically our if name equals main. I'm going to show you what our if name equals main is going to be. It's going to be maybe an input statement. What grid file do you want? And then something like that, and then we'll just make the grid game grid file name, and then the game, and then we'll have the game dot run. So clearly this is going to have to take the grid file name. Oh, so it's generally standard, even in Python, to use the like C++ case for class names. I mean, so if you look up PEP8, class naming, let's see, style guide, class names. Okay, so let's look here. We're going to click on class names. And so class names should generally use the cap words convention. Naming convention for functions may be used instead of cases, where the interface is documented, blah, blah, blah. So basically, this is the PEP8 convention for class names. So you see that variable names, on the other hand, type names of variables should use cap words. So that's type names of variables. Oh, type variable names, not variable names. Naming conventions. Anyway. Where's the... And then here's the function and variable names. So they call camel case here mixed case. Now, here's the thing about PEP8. Is PEP8 the law? The answer is, in this class it is, more or less. In real life, the answer is whatever standards, whatever conventions the current project you're working on has, you'll have to adopt those conventions. So even if you hate PEP8, even if you hate camel case, even if you hate some other random convention, you may have to use that convention on some project in your life. So in this class, we've decided we're just going to stick mostly to what PEP8 says. We're basically doing a PEP8 ---- standard, which is, there's a lot more stuff in PEP8 than what we're enforcing. For instance, we're not being very sticklerish about the fact that between every function, there should be 2 lines of blank thing, and between every line in the class methods, there should be 1 empty line. There's a lot of extra stuff in the PEP8 conventions that we're not really enforcing. But on the other hand, that's what we're doing so far. So even if you hate it, you just have to use it this time. And you see here it says always use self for the first argument to instance methods. The reason why is so that technically you can name it anything, but don't do that. Okay. So, interesting. Okay, so no, if you guys hate PEP8 standards, you should have heard me hating on PEP8 standards. Am I a big fan of them? No, I guess not really, but it is the standard for Python in general. It's the standard that the language comes with, so some people are very into that kind of thing. Okay. So what kind of things do grid games have? Let's say grid games they're going to have a grid. And so a grid needs a grid file name, so good news, we have that. Maybe we'll create a create character function. And so then we'll have player equals character. And maybe we'll say self.player.create character. And then, that's a good question. How many gremlins should we have? So let's say that we have, so let's say for I in range 5, so this is not quite going to work because we have to put in its starting position. So let's put in a starting position of 2, 2 for no reason, and the symbol is going to be G. So we see that this basically creates the game here, right? Because it creates the grid, creates the character, we put the gremlins in, say we, maybe initialize or set up gremlin. I don't know. Maybe we don't even need to set up the gremlin. So then, basically, the only other function here is going to be the run function. So I guess let's say it's like a maze game. So it's a while the player's position is not equal to the self.player.position is not equal to, and then of course we'll have to have some kind of win location. So maybe we can say self dot the grid dot at player position is not equal to E for the end. And then I guess what we'll do is we'll basically just say self.player.move. And then for I in range 5, really we should make this a constant. We can make this and then we can say something like and then I guess we would check to see if gremlins ate the player. And so that would be a lose condition. And I think that's basically it, right? You move the player, and I guess the other thing you might want to do is self.thegrid.draw, something like that. Now, of course, you might think, well, a lot of these functions are not implemented. A lot of this stuff is incomplete. And the answer is yeah, I know. I'm just writing it as we go. I'm just thinking of the kinds of things that we might want and need as we create this class, this set of classes. So I think this is a decent set of examples of things like that. So for instance here, let's say self.gridArray and make it some list. So basically these are all the functions. I think everything is defined now, more or less. Yep. So given that everything is defined, you guys could really finish this up, right? You could write your own little gremlin games based on this. In fact, I think, I'm definitely going to upload this to the GitHub. Maybe I'll upload this in the GitHub like, kind of like this. And maybe I'll finish the game in a way that I want to. And you guys can, if you're interested, you can finish the game however you guys want. Make yourself little grid games. You should steal code from your previous homework. That's a good question. Do goblins hate each other? I think they probably have to, right? If goblins hate... Oh, okay, they only hate... Okay. Well, it's good to know. It's good that you guys are making... you're in consensus. Okay. So basically my idea for the grid files, at least, was they were going to be some kind of strings. And they would basically either be... Maybe an underscore would represent an empty space. The S would represent the starting position for the user. The E would represent the end position. Maybe P would represent the player. So this is open, start, end, player, gremlin, blocked. Yeah, I feel like goblins are kind of chaotic evil, and gremlins are probably more like chaotic neutral. Gremlins don't really hate anybody. They're just you know, they just cause havoc because they like to. So anyway, I think this is a definite. This is a pretty good example. So, okay, I'm gonna stop here on this example, but I think basically, you know, we've already written 70 lines of code here, so I think you could probably fill this in and make yourself a little game. So another thing that I decided to do, and I'll do this as an example, is something called operator overloading. And I want to show you operator overloading now. So I made this little vector class, and I also made this polygon class. I'll upload all of this stuff to the GitHub, but for now, let's just look at the vector class. So if we look at the vector class, we see that there's this underscore underscore add and underscore underscore rmul, which ignore this for now, underscore underscore mul and get item. Like, what are all these things doing? What are all of these? And you see that Python has colored them differently. So if I create just a random method, you see that it's colored yellow, whereas Python, or PyCharm at least, knows it colored this like, you know, light purple, so it knows that there's something different going on here. And so the question is, what is going on with these functions? And the answer is, okay, so the first thing I'm going to do is comment all of this code out so that we can play around with this a little bit. So basically, this vector is supposed to represent like a two-dimensional vector. And so you see that it has an x-coordinate and a y-coordinate, and so we set self.x equals x, self.y equals y, and so that's really what it is. So if you guys know anything about like linear algebra, what you know is that if you have two vectors, right, you have v1 is, say, like 1, 2, and v2 is, say, the vector 2, 5, you're allowed to add vectors. And so if you add v1 plus v2, you're going to get, I guess, what, 3, 7. So if we create a vector, 1, 2, and we create a vector, let's call it v1 equals this, and v2 is equal to this, oops, then the point here is that we want to be able to say this. So ignore this polygon class. You can look at that when we get to the GitHub stuff. So this is what I want. What I want is this. I want to be able to say v3 is equal to v1 plus v2. And as it turns out, if you implement this underscore underscore add function, let's run this. And then, of course, we have to look at the output. It says I'm being added. So clearly what's happened here is this plus sign is not a plus sign that's operating on integers. It's not operating on floats or strings even, right? Strings have a plus sign, but it's actually operating on vectors. And so it recognizes, Python recognizes that v1 is a vector, right? It recognizes that v1 is a vector and it's calling the plus function. And so inside of the class, this is what the name of that is. It's kind of like doing this, except that Python doesn't like plus sign as the name of a function, so we need add. So I am being added. So what it does is it creates a copy of itself and then adds the other vector to that copy, and then it returns that copy. The reason why it does that is that otherwise, if you don't do that, then it'll modify the original class, and you don't want that. Because if you say something like, if you said something like v3 is equal to v1 plus v2, then if we didn't make the copy, then v1 would be modified. So then v1 would be so for every operator, there's a underscore underscore something that lets you change that operator. The answer is yes, more or less. Yes, yes, yes. So you can't do underscore underscore plus, and the reason why you can't do that is because it's not a valid, it's not a valid Python variable name, right? Because Python variable names need to have, only capital or lowercase letters, numbers, and underscores, right? So it can't have plus signs, it can't have division signs, it can't have any of that. So basically, if we print out v3, then I want to show you what happens. So let's print out v1, v2, and v3. So now normally, most classes, when you print them, so if I just make a new class, let's just create a polygon, and let's print out the polygon P. Well, let's just, okay, so class, rando class, pass. There we go. So, all right, let's run this code. Normally what happens when you print out a class is this. It's going to say rando class object at some memory location. That's what it's saying here. But you see that for the for this class, for the vector class, it actually prints out these numbers, 1 and 2, 2 and 5, and 3 and 7. Well, what the heck? How to do that, right? Well, as it turns out, it has to do with this function. So this is the function that you have to implement. Repr if you want something to print. And so basically what repr is it's asking what is the representation, it's asking for the printable representation. That's what the repr means. In other versions of Python, or you can even do this, if you implement str, this will work as well. But the only reason why I implement repr instead of string is that this is the kind of Pythonic recommended way to do it. This is the way that the documentation wants you to do it now. So yeah, okay. So let's look at some other things that I've implemented on this. What is getItem? Well, you know how a vector has two slots, right? It has an x and a y. What if I printed out v1 of 1 and say v3 of 0? So this should print out the y coordinate of v1, which is 5. 2. And this should print out the x coordinate of v3, which is 3. So we see that it did that. Now, how did it do that? Let's add a print statement. So you see here, when we do the array brackets on this class, it's actually accessing this getItem method. It's not accessing the thing as an array. It's asking the class, do you have a getItem method? If you do, what is the thing at that index? So if index is equal to 0, you return self.x. If index is equal to 1, you return self.y. I mean, technically, and I'm just having it return 0 if it's neither of those, but I mean, that's probably even a bad thing in Python. Probably just want to throw an exception. Really, this is what you would really want to do. You'd probably want to raise like a value error, or an index error, something like that. Anyway, so we see that is how you will be able to access something as if it was an array, or technically a dictionary. Index, there's no limit on what index could be. Index could be so we could actually do the same thing here. Let me see, did I screw something up? It doesn't seem to like it. I don't know. Well, I guess the good news is it'll short circuit, so it shouldn't create a problem. Or I guess we don't even need the dot lower. Let's just ignore the dot lower part, and then it'll be happy. So we see here that we're able to access this this data using the getItem function. And then the other thing I implemented was for the other polygon stuff was the mul function and the rmul. The difference between mul and rmul is that this function takes care of when you have us times something else, and this function takes care of when you have something else times us. Is it possible to suppress the memory location print statement? The answer is yes, if you implement this repr function, right? Rando class doesn't have a repr function, but if I implement that, then as simple as that, it'll just print this out every time, and it won't tell us the memory location anymore. Okay. So I just want to show you what the rest of this stuff does before I let you guys go. So this polygon class, you should play with the code here. Let me just flip this out and run. So what this thing does is it draws, it basically draws polygons on these regions. So you pick the number of sides in the polygon and then it draws it. So let me just show you what it's doing, so that when you go and play with it, it does this. And that's really all you need to know, is that it draws stuff. So, okay. I guess I'll leave you guys with that. I'll upload all of this. So next time, we'll talk about testing. I guess I didn't get to testing. Maybe I'll make a separate video on testing, and that way Ben's students can also have it. I think it's going to be a video where we talk about what we expect for Project 2 in terms of the test suite. So, because instead of doing a design, we're going to ask you to do test suites for your project, which means that you're going to write tests for your functions. And basically, I'm going to show you exactly what we expect in terms of that before you ever see that on a real project. So on Monday, I guess, we'll do that. Or maybe I'll just release a separate video talking about a little bit about what we expect on testing on projects, but I'll definitely go over it on Monday in class. All right. I think that was good. So I think I'll upload all this to the GitHub, and the only other thing to say is that everybody should go and play around with operator overloading, create your own classes, finish the grid game. How long until project grades are out? I mean, the projects were submitted yesterday, so the answer is it's going to be a while. Those have to be graded individually by TAs, and so that takes a few weeks, 2 or 3 weeks. All right. All right. I think that's it. I'll let you guys go. I'll upload this to the GitHub. Have a good rest of your day. Peace out.